Hello and welcome to Module 19 in our C language series. This module is going to focus on expression parsing, and this session is one of 3 for this module. Let's begin with the question. Have you ever wondered how you would create a program that takes as input a string containing a numeric expression and then produces the desired result? If you think about it, it's the compiler that would get involved here. If you're working with Python, for example, then it's the interpreter. Have you ever been mystified by how a high-level language could convert a complex expression like this one into instructions a computer can execute? And again, it's the compiler or the interpreter that needs to get involved. The process itself is known as expression parsing, where the compiler or the interpreter works along with the grammar, if you will, of the language to evaluate these expressions and then give us the desired result. Talking about expressions, and throughout this module, we will be sticking with numeric expressions. What would these numeric expressions contain? And of course, they would contain numbers, operators, maybe parentheses, as well as variables. Now, talking about parsing, there are two main categories of parsing. One is the top-down parsing category, and the other is bottom-up parsing. The parser we are going to build is called a recursive descent parser. It belongs to the top-down parsing category, and how it gets its name will be clearer when we get down to writing the code building that parser. Now, one of the steps in parsing is to evaluate expressions. So if we look at an expression like this, and if we think of evaluating from left to right, representing that through a flow chart would be something like this. So we start, we get the first unit, which would be 12. We then ask if there are any more units. In this case, there are, so yes. We get the next unit, which is an operator. And we get the next unit as well, which is 2. We perform the operation, and then we go and ask, are there any more units? In this case, there are. And so we get the next unit, which is the multiplication operator. We get the number 4, and we do the operation. At the end of this, x is going to contain some value. Right? Now there are no more units. Right? So any more units will yield no. And we'll print the result and end the process. But have we got the right result? And of course we haven't, because just evaluating left to right, we are not accounting for the precedence of one arithmetic operator over the other. In this case, the multiplication operator has precedence over the subtraction operator. And so the parser we build needs to make sure, or has to be written so as to make sure that we take this precedence of arithmetic operators into account. Right? Before we even write the parser, we need to understand how to dissect an expression. So if we have an expression like this, the question we would ask is, how many components are contained in this expression? And of course, they would be all of these. Right? Each of these components is known as a token, and all tokens have one common characteristic, which is indivisibility. So we break down the expression into its individual, indivisible components. Right? And of course, we will use a function to do this. The function would also have to take care of skipping over spaces in the expression, tab characters, as well as detecting the end of the expression. Now a little more about the function itself. The function will return a token every time it is called. So we'll call this function from within a loop, maybe a while loop, for example. The function would need a global character pointer to help us move along to the next token. And this pointer will point to the array that holds the expression. The function will also return the type of token, and the type of token could be variable, number, or delimiter. Remember, delimiter would include brackets or parentheses as well as operators. There are certain assumptions that are going to go with our code. One is only numeric expressions will be entered as input. Second, all variables are single letters only. Third, each number is a double. And the last is that error checking is kept to the minimum for ease of understanding. You could, if you wish, include more error checking in your code later on. Now, keeping this in mind, let's write some code to implement a routine to dissect a given expression. And to do that, of course, we need to go to code blocks. We need to start a new project. So click on File, New, and then click on Project. Click on Console Application, and then select Next. Click on C, click Next. Give your project a name, something like that. Click Next and Finish. So now if you click on sources, you see we already have main.c and there is some code already there. But of course, we need to modify this code, which we will do later. So click on File, then we move along to New and File, and then C++ source is selected. Click Next. Leave this as is because we are writing our program in C. Click Next. And now click on the three dots. Give your file a name. Save. And now both these need to be selected. So click All and Finish. So now you see both the files appear here. We're going to be writing the code for this one first, which is already open, right? So we can start with hashtag include stdio.h and then hashtag include stdlib.h and hashtag include string.h and hashtag include ctype.h. We have some directives, so hash define, and that's going to be delimiter 1, and again hash define, and that's going to be variable 2, and again hash define, and this is going to be number 3. Instead of using the numbers, we will use these names in our code. The function, there are two of them, void get token, so that's not going to return anything. No parameters there, so you can also put in a void there, or you could leave it blank. Both are valid. We have another function returning an integer, that's going to be int is delimiter. I'm just going to call that is delimit, and that's going to take a character type parameter. Just call that C. And we have char token, which is going to be 80 bytes, right? And we have an int type variable token type, right? Now remember, we need a global character pointer, which we will define in main.c. So here we need to use a storage specifier for that. So here we say extern char, and we're going to call that prog st. This is going to be a pointer, right? So star prog st. Okay. Now that we have all of those, we can start our function void get token, no parameters, and here we need char start temp. Why we need it, we will see shortly. Token type, we can initialize it to 0, and we could also initialize temp. Temp is going to point to token. Okay, so it's going to hold the address of token, and like I said, we'll see why we need it shortly, right? We could also put in star temp equal to a \0, indicating it's got a null there, right? Now we check if not star prog st, right? Which means there's a null there. then what we do is we just return. Otherwise, we need to skip over any spaces that may be present. So while is space and star prog st. So we just move the pointer forward. So plus plus prog st, skipping over the spaces. Once we've moved over the spaces, then we need to check whether the token is a delimiter, a variable, or a number. Right? So if strchr, and we'll pass in all the operators. So that's positive or addition, subtraction, multiplication, division, exponentiation, modulo, equal to sign, and parenthesis, comma, star prog st, right? Then within this block, we say token type equal to delimiter, right? And we'll have a printf statement, and we'll print token %c and delimiter %d \n, comma, and here we'll have star prog st, comma, token type, right? And then star temp plus plus equal to star prog st plus plus. Okay. Now, if the token is not a delimiter, then we check if it's a variable. So else if is alpha star prog st, then now we have a while loop, while not is delimit star prog st. So is delimit, it's important to know, is going to return of 1 if it encounters an operator, that is, or brackets, or some other characters which we look at when we're writing the code there. But it will return a 0 if this is a letter, right? So that is a letter of the alphabet, of course. So while not is delimit star prog st, star temp plus plus equal to star prog st plus plus. Okay, I hope that's clear. And then token type will be equal to variable, right? And of course our printf statement, token %s, because we're going to be using token itself for printing this out, comma, variable %d \n, comma, token, comma, token type. Okay. Now, if it's not a delimiter and not a letter of the alphabet, meaning not a variable, we check if it's a number. So else if is digit and pass in star prog st, then again we call is delimit. So while not is delimit star prog st, star temp plus plus equal to star prog st plus plus. Okay, and then token type equal to number, and printf statement and again token, and that will be a percentage S, and delimiter, sorry, this will be number, and that will be percentage D backslash n, comma, token, comma, token type. Right? And now, after this, we just say start temp equal to backslash 0. Right? So we end the string, so to say. Right? Now that completes the code for get token. The next is int is delimit. Remember, that's returning an integer. And it's bringing in a parameter of character type, char-c. And within this function, we just check if strchr, and of course we pass in all those operators, so plus, minus, multiply, divide, exponentiation, modulo, equal to sign, and our parenthesis. And we're checking for these in C, right? So C is any one of those, or C is equal to 9, which is a tab character in the ASCII code, or C is equal to backslash R, which is a return character, right? Or the carriage return. Remember, backslash N is a new line character, or C is equal to 0, which is a null. Then return 1, otherwise return 0. Okay, so that's all for this file. Now we can move on to main, right? So just click here, and of course we need to change this particular printf statement, but before that you just put in the function name here. So void get token, right? And we have char expression of 80 bytes, right? And of course we need a global character pointer, so char star prog_st. Okay, and now this printf statement will be changed to enter an expression, and of course we need a scanf, so scanf, and we're going to allow entry until the user presses the enter key, right? Comma expression. Now we have an F flash, of course, and we have prog_st initialized to expression. Okay, now while star prog_st, meaning while that's not a null, we just call get token. That completes the main function, right? So now we need to build this project. Let's click on this button. You want to do it separately, that is. Then we get 0 warnings. Once we have that, then we can run it. So enter an expression. Let's say Z plus 100. Let's say minus W multiplied by L divided by 2. So Z is a variable, that's correct. The plus sign is a delimiter. 100 is a number. Negative sign is a delimiter again. The bracket is a delimiter. Now here we're getting W and 0. So why we're getting that, we need to check. It is a variable. Then we have the asterisk, which is a delimiter. L, which is a variable, bracket is a delimiter, this is a delimiter, that's the division sign, and then we have 2, which is a number. So we only need to check what this 0 is about. So come back to the code, and that will be here. We will put in a statement saying star temp equal to \0, just to end that string. Okay, so now let's build it. Let's run. Now we enter an expression, let's say S plus 200 minus B multiplied by F divided by 4. And now you see we don't get that 0, right? So you can play around with this program. Okay. This ends our part 1 or the session for today. In the next session, we proceed to build the parser, and the parser that we build in the next session will evaluate expressions with constants only. And then, of course, in the third session, we'll introduce variables. So till the next session, take care, stay safe. Bye.